In this video, we're going to go over how to do some problems from the Chapter 4, Section 3 assignment, which is on functions, and this is going to be some examples from the alternate assignment. So we're going to start with looking at this kind of function box thing at the top here. You can see that the independent variable is also the x value. It's the domain of the function. It's the input. It's usually x. The dependent variable is the y value, it's the range, it's the output, and we can also call that f of x. Alright, so that's just some vocabulary. Here's a problem. Carmen attends a school with a dress code. She went shopping and found acceptable shirts for $15 each. Her mother has allowed her to buy up to 5 new shirts for the school year. So we have to figure out what's the independent variable, what's the dependent variable. Could we write a function, write an equation that would express this? So let's see, the independent variable is, in this case, it's the number of shirts, and the dependent variable is the cost. And the reason that is, usually cost, if there is a cost, will be dependent because it depends on how many shirts you buy. So if we wrote this, if we typed a statement, we could write a statement that would say the cost depends on how many shirts you buy. Also, I'll say it the way they do, the number of shirts she buys. If you can write the sentence like this, then you can see that the first part, before the word depends, that is the dependent variable. See, total cost, they're the same thing. So the words before depends is going to be the dependent variable. After the number of shirts, I'll double underline that one, that is going to be the same as the independent variable. It depends on something. What it depends on is independent. So we could let the number of shirts change. We could say 5 or 4 or 3 or 2 or whatever, and the cost will change depending on what that number is. So an expression, an equation that represents this is right here. We've got f of x equals 15 times x, because x is our number of shirts she buys. I'm going to put an x there. And so there's x. I put it in the wrong spot here. That's the x. And the total cost would be the y, or another way of writing y in function notation is f of x. So you can say that f of x, the total cost, is equal to 15 times the number of shirts she buys. Now a domain for shirts, you can't have 1.5 shirts. And she's not going to buy 0 shirts. I guess you could put 0 here. But they said that the reasonable domain would be 1 shirt, 2 shirt, 3 shirt, 4 shirts, or 5 shirts. The reason we stopped at 5 is because of this sentence. Her mother has allowed her to buy up to 5 new shirts. Up to. So it doesn't have to buy 5 new shirts. And then the range would be, what is the cost for 1 shirt? Well, that was 15. For 2 shirts, you just take 2 times 15. That'd be 30. 3 times 15 is 45, and so on. So these are the range values. Now, the reason we just make a list with commas between them is because shirts are not, you can't have decimal parts of a shirt or fractional parts of a shirt. So we just want the whole numbers that would align with what she's going to buy. Okay? All right, so let's look at some more examples. On the worksheet, your first example is that Molly's making greeting cards for 5 of her friends. Each card is to have 5 ribbons. You have to figure out the independent or the dependent variable. The best way to do this is to write a sentence, just like I did with the above example, with something depends on something. So let's see, how could we do this? The number of ribbons used or the number of cards made? The number, let's try it this way first. The number of ribbons used depends on the number of, it would have to be the other one. Now, does that make sense? I guess what cards made. The number of ribbons used depends on the number of cards made. Well, that makes sense because the more cards you make, the more ribbons you're going to use. So up here, we said that the first part before the word depends, the cost in this case, was the dependent variable. So let's go back down here. What do we have before? Here's the word depends right here. There's depends. What is before that? Before that is the number of ribbons. And we're saying that whatever is before that, that is the dependent variable. rid of some of this. Okay, the number of cards used then, that's after the word depends, or the number of cards made, I mean. And I double underlined that one to match up with the independent variable, because that is afterward the word independent. Forgot a letter there. That's after the word depends. So that is the independent variable. Now then you have to write a function. That just means write an equation. Well, let's see. Every card she makes has 4 ribbons. So the x is, let's go back and look at our example. The x is the independent variable, and the f of x is the dependent. So the x is the independent, that's the number of cards made, and the f of x is the dependent. That's just like y. So f of x is equal to what? If I have 1 card, I'd use 4 ribbons. If I have 2 cards, I'd use 8 ribbons. So I have to just take the number x times 4, because every card is going to have 4 ribbons. So this makes sense, because if I change x to be the number of cards, which is what I said the number of cards was, then times 4, then I will get that. A reasonable domain. Well, what's the least number of cards? I guess you could use 0. I can call it. Let's see, how did they write their domain? They wrote their domain as x values, and then they just put it. So I'll do the same thing. And then I'll say that x could be 0. That's 0 cards. 1, 2, 3, 4. It says she's making greeting cards for 5 of her friends, so we'll stop at 5. And then the domain, I mean the range, would be what we get for f of x, or we could put y here. And that would be, well, let's see, at 0 cards, 0 times 4 is 0. So that's our first range value. At 1 card, 1 times 4 is 4. At 2 cards, 2 times 4 is 8. 3 cards would be 12. 4 cards would be 16. 5 cards would be 20 ribbons. So all I did there was I plugged x, the values of x, the values of my domain, into my function, 4 times x, and then I found out what I got. How many ribbons will Molly use if she makes 3 cards? Well, we did that one. At 3, that would match up to, let's see, 3 times 4 matches up to this one right here at 12. So 12. Is that it for that question? Oh, one more. How many ribbons will she make if she uses 5 cards? So you just do the same thing. You plug 5 into here for 4 times 5, and then you put your answer down here. Okay, the next page of the worksheet talks about a little bit more about the same thing, and this time they ask you to rewrite each sentence using the word depends. And then you can remember that once you do that, we did it here, the part in front of the depends, the phrase that we put in front of the depends, that is the dependent variable. So we just have to remember that before depends is the dependent variable. So here's an example. An employee who works longer hours will receive a larger amount in her paycheck. Let's rewrite that. The amount of the paycheck depends on the number of hours worked. The part in front of the word depends, amount of paycheck, that is the dependent variable. After the word depends is the independent. Then they did a box with several books weighs more than a box with just a few books. The weight of the box depends on the number of books in the box. The part in front is the dependent variable. The part after the word depends is the independent variable. Okay, so we need to rewrite this sentence. A very large animal will eat many pounds of food. So, how could we say this? The bigger the animal is, or the size of the animal, will eat many pounds of food. So I think that we could say this as the amount of food depends on the size of the animal. Now let's see if that makes sense. The amount of food depends on, yeah, because the bigger the animal is, they'll eat more food. So now the part that is in front, the amount of food, is the dependent variable. That's supposed to have one underline. So you're going to write for dependent, you're going to write the amount of food. What is it? The independent variable is the size of the animal. That's the independent size of the animal. Size of animal, I probably should have wrote. Okay, let's see if we can rewrite this sentence. The fire was very large, so many firefighters were there. Again, the first part is going to be the dependent. The amount of firefighters depends on what? It depends on how big the fire was. Again, the size of the fire. Now you could say this slightly different, but the basic thing is that the bigger the fire is, the more firefighters, so the amount of firefighters depends on the size of the fire. And then this part is the dependent. I'll let you do that part. Dependent. And the part after the word depends is the independent. Independent. The temperature of the water on the heated stove rose each minute. So the temperature of the water depends on the time that it's cooking. Time is almost always independent, so that's going to be after the word depends. So the temp of the water depends on the amount of time. The restaurant bill was low because only a few meals were ordered. The cost of the bill, or the cost of the bill, the amount of the food, depends on how many meals were ordered. So you're going to write something like that. The cost is going to depend on the amount of food. Okay, in this section, you're going to figure out the independent and dependent variables again, and then write a rule, and then answer a question about that. Evaluate when it's a given thing. So a zoo charges $6 for parking and $17.50 for child. You could say that the cost depends on, how many kids go plus the parking. Number of children, the cost of admission depends on the number of children. And then there'll be a plus parking on that. So the equation would be the cost per child, $17.50, plus the parking fee, which is just a flat rate. And then when it says evaluate the function, that means just take 4 and put it right here. So you'd have $17.50 times 4. Right here they do that. And then they have to add that parking cost. So here's how you evaluate that. And then you do it again, a separate problem for when you have 10 kids going. Alright, so here's your limo service charges $90 per hour. So the dependent is the total cost. So that's what you're supposed to write here. The total cost of the limo depends on the hours. That makes sense. It's $90 per hour. The function is when you're going to write the actual equation here. Whoops. F of x is equal to, well, there's no other thing here. It's only the per hour. There's no flat rate on top of that. So it's just going to be 90x. Evaluate for x equals 2. You just put f of x, not capitalized, x equals 90 times 2. And you figure out what that equals. And then you do it again for 90 times 7.5. And then you just write what your answer is. Okay, here's another one. A computer support company charges $2.95 for the first hour plus $95 for each additional hour. So this one has something times how many hours plus a flat rate. This one's a little bit harder. Okay, so the dependent is the total cost of the how much it's going to take to get your computer fixed. The independent is going to be the hours. This part is a little bit trickier because we have a flat rate. I'm going to put that first, $2.95 plus per hour. But they're not going to charge you They're not going to charge you $95 for the first hour, only for the hours after the first one. So if they had your computer that they're working on for 5 hours, they would only charge you for 4 additional hours, which would be x minus 1. So this is the function. and then you're going to evaluate that for some different values here. When x is equal to 3.5, so we'd put 3.5 right here, and then take 1 away would be 2.5. So it would end up being 295 plus 95 times 2.5. And then we're going to do it again, a different problem when we're going to put 8 right here. So that would really be 8 minus 1 is 7 times 95 plus the 295. So I hope that helps you make some progress on this worksheet. Please email me if you have any extra questions on finishing this worksheet. Thank you very much.